appreciate y'all being here today. We got quite a few people with us today. As we say, this is one we do every year. Try to always do it in January to kind of kick off the year for webinars. For some of you, this will be a lot of good information. For some of you, you may only get a few tips out of it. But, as electric becomes more and more, prominent on today's vehicles, we have to be more better trained to be able to use a multimeter. Same thing if you do any tech events. If you notice at a tech event anymore, almost every station requires you to be able to use a multimeter. So this is a good refresher. Multimeter will flat talk to you if you use it properly. And there's a lot of things that a multimeter, can do, but you got to use it to get familiar with it. A test light only tells you you have something. You can't tell the difference between, the brightness of the bulb between 12 volts and 14 volts in so many things anymore. If you don't have the right voltage, close, only works in hand grenades and horseshoes. That's, it has to have a certain voltage, and you have to be able to use your meter right. And again, there's many different things you can use on that meter that can help you troubleshoot. Feel free, if you have any questions as we go through this, type them in. I will answer them as I can, or worst case, we will go through them all at the end of the presentation. And remember too that this will be available again in recorded version tomorrow. And then also generally it's loaded up on YouTube, our website, many places you can see it. Or if you have any questions, please don't hesitate to reach out, send me an email, send me a text, whatever, if anything I can do to help you. But when we say multimeter is a meter that does multiple different things. And a lot of techs use it for one or two things. They use it for a voltmeter, they may use it for an ohmmeter. There's all these other symbols and functions on there they don't ever take advantage of. Or they don't even use the voltmeter, like they could, that can really help troubleshoot issues. So there's kind of the basic functions and a little bit more of some more in-depth ones we're going to talk about at the end. But again, on all these things, the only way you're ever going to get good at using a multimeter is to use it. Take your test light home. I'm not going to tell you to throw away, because if you bought it off one of the tool trucks, you probably paid too much for it. But break your meter out, use it as much as you can. Whether you're using your own meter, you borrow your buddies, or you're at a tech event and you're using the one at the station, you always got to make sure that meter is ready to use. For today's presentation, we're showing an X-Tech meter. Doesn't matter as long as you buy a good meter. And I'm not here to try to sell you meters. Just make sure you buy a good one. It's not something you should buy at the discount tool store, nor is it something you ought to buy the most expensive one off the tool truck just so you'll be the coolest kid in class. Buy a good one, but don't overbuy either. Depending upon brand, on the X-Tech that we're showing you here, it's got a little symbol comes up when you turn it on. It looks like a AA battery. If that symbol stays on, it's telling you your meter has a low internal battery. If you want to make sure you're getting accurate readings, you should replace it. I will say you should treat your meter like a smoke alarm. Once a year, put a new battery in it. Again, not here to sell you batteries either, but you want to buy a good one. If you invested the money in a good meter, don't buy some generic battery that's going to possibly leak acid and ruin that meter. So buy a good one. Again, depending upon meter, some of them have the AA battery symbol that we just showed. Other ones have a little symbol, kind of looks like a car battery. And then other ones actually will come across the screen and say BATT. Doesn't matter, they're all telling you the same thing, is your internal battery's low. The other thing you want to do is make sure you check your leads. Turn your meter to ohms, which is a Greek letter omega, looks like an upside down horseshoe, is turn it to that, touch your two leads together. Your meter should zero out. If it doesn't, you either have bad leads or you have a meter that's out of calibration. We came with a high-tech tool years ago. You all know it as a paper clip, but take a paper clip or just a good piece of wire, strip the ends of it off, take your two leads out and put that wire in. That way you're taking those leads out of the equation. You're checking just your meter. If it doesn't zero now, your meter's bad. Just like talking about changing the battery once a year, meters, you ought to send them in and get them calibrated. What's the shop supposed to do with a torque wrench? Send it in, get it calibrated. Again, certain meter brands I do like better just because they do have better calibration programs. They have a fairly quick turnaround. Other ones, You know, you almost have to have 2 meters because it'll take that long to get the other one back, that by the time it does come back, it's time to send the other one in. So it did 0, so now we want to check our leads one at a time. Take your red lead, plug it back in, and put the tip of it in where the black lead should go. Now you're checking just the red lead. Should 0. If not, says, hey, that red lead is bad. Do the same thing with the black lead. Again, all we're trying to do is make sure our meter is accurate and ready to go. I've had people tell me, well, I just subtract the difference every time. Yeah, that's not very good. You can't, do the same thing with torque wrenches. Well, in order to get 120 pounds, I take it to 135 just to make sure it's right. Again, you got to make sure it's accurate for what you're trying to do. The other thing, you always want to make sure you're familiar with your meter. That's why whenever we do, in-person meter classes, I always tell people to bring their own meter. Why? Because we go through it and say, hey, this is where the function is on yours, or this is what yours means. The other thing, you got to make sure if you're what type of meter you have. Most anything that's digital anymore is an automatic ranging meter. What does that mean? It's going to move the decimal, put it in the best spot to give you the most accurate reading every single time. 99.99% of the time, the meter is smart and all of us put together, leave it alone. The one time I have found that it can be of benefit to using the manual range is if you're in very low voltages, like less than 2 volts. Sometimes a automatic ranging meter has a hard time ever locking in. So there's times, use the range button, toggle through, and put it on the right scale, and it will lock in faster. What you always want to make sure you do too, though, is reset it when you're done. Automatic ranging takes care of all that for us, but if we forget to have it on manual range on, say, a 20-volt scale, and you go stick in a wall outlet, what's it going to read? It's not going to read 20. It's going to read OL, simply because you told the meter the highest it should see is 20. That OL is out of limits or out of luck, whatever you want to say, but it's beyond the range. So it can get you in trouble because you'll think there's nothing there when in fact it says, no, you're just above what that range is. Again, depending upon the brand of meter, some of them up in the corner will say manual or MAN. Others will say auto. You just got to be familiar with it. Best thing I always tell people is turn it off, turn it back on, and usually it defaults to the automatic range. The other thing too is for the voltage or AC voltage versus DC voltage. Depending upon brand of meter, some of them just have voltage in one knob position, and you got to use the mode button to toggle between AC and DC. Other ones have a different knob position between AC and DC, so you got to make sure you are using the right one. This one here, you see we're on AC right now. To toggle it back to DC, you'd have to hit that mode button. The other thing you have to make sure is what your meter's capable of reading. Most of your better meters will go up to 1,000 volts. If you should find something that's over 1,000 volts, it would also display OL, simply saying it's beyond the range of that meter. What I've seen, though, at times people will buy a generic meter or a economical meter, and it may cap out at 400 volts. So as we get into EV market, or if you're doing any type of industrial maintenance as well, where you're getting into voltages above that, your meter can't read it. And that is definitely not a time you want to stick your hands in somewhere you shouldn't, assuming there's no power there. Again, before we showed AC, now we're on DC. The screen now changed and shows DC. And again, most meters will go up to 1,000, both on AC and DC. Okay, well, now we're actually going to use our meter. And the first thing we're going to talk about is a voltmeter. People think a voltmeter is a lot more high-tech than it actually is. But we've got a battery sitting here. The battery's at 12.5. We put our red lead on positive and our black lead on negative. What does our red lead read? 12.5 volts. What does our black lead read? 0. What is the difference between those two? 12.5. That is the only thing that voltmeter is doing, is telling us the difference between those two different points. That if we were to take that meter and we swap the two leads around and we put black on positive and red on negative, still going to be the same thing, other it's going to read a negative 12.5. But that's the only thing a voltmeter does, is tell us the difference between two different points. Now, if we take that same battery, but we grab a starter and a couple of cables, this could be on the bench or this could be on a truck. But if we take our meter and put it across a starter, red still on positive, black still on negative, still going to read the same thing. Red's still going to see 12.5, black's still going to see 0. Now, the key right now when we do all these first set of checks is no current flow. You cannot have voltage drop if you don't have current flow. So this is just at rest, no current flowing. Now, I can move these leads anywhere I want to. As long as red's on positive and black's on a negative, still going to read the same thing. Now, this is where, we can extend your ability of using this meter. Is right now, most technicians only ever want to use a voltmeter, red on positive, black on negative. Can we use a meter positive to positive? The answer is yes. That if you look at the drawing right now, we have the red lead on battery positive, and we have the black lead on starter positive. Both of them read 12.5, so that says there is no difference between those two voltage reads, which without any current flow, that's exactly what we should read. Now, if you had your meter hooked up like this and your meter did display 12.5, what should that immediately tell you? And the answer is there's a break in that wire. Now, generally this won't ever happen with big starter cables. Generally a big 1/aught, 2/aught cable doesn't break. But these same rules apply to any circuit on that truck. And we've done this on boards before, and people will skip right over because their first reaction is, ooh, 12.5, that's a good reading, and they skip right over. If you're paying attention, that's when the bells, should be ringing and lights going off saying, hey, here's my problem. I got a break between here and here. Now, that could be a break in the wire. It could be a blown fuse, trip breaker, bad connection, anything but saying there is a break between point A and point B. One of the biggest things I always tell people that can help them when they're working on electrical is grab you a pad of paper and a pen, draw out the circuit. Where's it supposed to go? Hey, I should have power here. It goes there. We did some checks on truck manufacturer for the aux pin of the 7-way. And that circuit had probably 20 different connections in it. And it wasn't open, but that circuit had a lot of voltage drop. And we could use that voltmeter and walk all the way through that circuit from point A to point B, from point B to C, C to D, walked all the way through it to look at the voltage drop of every single part of that circuit. That way you can go back through and says, yes, I have a voltage drop. And by isolating it down, I can tell you it was a voltage drop between the fuse panel and the bulkhead connector going through the firewall. So voltmeter can flat talk to you using it this way and walking through the circuit. Now, if I can use a voltmeter positive to positive, can I use one negative to negative? The answer is yes, same thing. Now, right now I'm going to see 0 at the battery, 0 at the starter. Difference is still 0. I have no voltage drop. Now, everything's fixing to change. Now we do have current flow. And for simplicity, we're going to show two different meters just so we can compare the two a little bit more easily. But I got one meter going across the battery. I got the red on positive, black on negative. What does my red lead read? 8.5 volts. What does my black lead read? 0. So I have 8.5 across the battery. Obviously, I've got a pretty healthy load on because this battery was 12.5 a minute ago. So we've pulled that battery way down. That starter's really cranking the engine. I've got my second meter going over across the starter. Red's on positive, black's on negative. What does my red lead read? 7.0. What does my black lead read? 0.3. The difference is 6.7. So if I look at this, my voltage drop in this entire circuit is the difference between 8.5 and 6.7, which is a drop of 1.8 volts. So somewhere in this circuit, I've got a huge voltage drop. How do I find it? I can very easily now use my meter, as we talked before, and look at it step by step. if I look at my positive cable, hook it back up from positive on the battery to positive on the starter, I got an 8.5 at the battery. I've got 7 at the starter. Difference is 1.5. Now, we all took algebra years ago. Swore we'd never use that. But what is the basis of algebra? If you knew 2, you could always find the third one. So overall, we had a 1.8 volt drop. We just checked the positive. We had a 1.5 volt drop. What's left over? 0.3. So if we do our next check on the ground side, battery negative to starter negative, difference is 0.3. So we know we did all of our checks right. Now, if I was going to work on this truck, where would I start? The positive or negative? Positive. I've got 5 times as much voltage drop on the positive side as I do the ground side. If I was going to work on this truck too, where would I start? What's the first thing I would do? More often than not, clean, retighten, retest. That anytime any of that stuff gets disturbed or a truck gets some age on it, you're always going to have connection issues, either at the batteries or at the starter. And if you look at a starter, how many connections are on a starter? That you've got main cables, you got charge cables, you may have cab feeds. There's a lot of different cables on those. So I always tell people, take them apart, wire brush them, make sure any of the protectant sprays they put on them, you know, one OEM uses something that almost looks like road tar. You got to get all that stuff off, clean it, put it back together, make sure your stack up's right. What do you mean by that? Well, when they built that truck, they knew the right order to make sure everything fit on it and compressed down for a good connection. That if you put one on backwards or whatever, you may not get all of them stacked up properly and not get the best connection you can. So I always tell people, yeah, pay attention, clean them, tighten it, put it back together, retest it. Now, a little bit of a trick question on this though is we went through and we did this test and we had a 1.8 volt drop in our cables. Is that a good or a bad reading? If you follow along with TMC's RP129, the spec for cranking cables on a heavy duty truck like this, you'd be allowed 0.5 volt at 500 amps. We had 1.8, so it's bad, right? We don't know, because we don't know how many amps that starter's pulling. That if you don't know what your load is, it's not a fair test. Now, going through and troubleshooting it is still valid, but that is why they make the carbon piles, the voltage drop testers, whether it's ohmmeter, Midtronics, whatever. They do a test to simulate that load with a fixed resistance, and they can tell you if it's good or bad. So if you are troubleshooting a cranking or charging system, you have to use that type of piece of equipment to do a fair test on those cables. Otherwise, you could spend all day, because again, 500 amps, 0.5 volt load, or 0.5 volt drop is allowed. If you pulled 1,000 amps, now you'd be allowed a 1 volt drop. If you pulled 1,500, you'd be allowed a 1.5. So if this was the middle of winter, very thick engine oil, very hard to crank, and that starter's pulling 2,000 amps, which it can do, you would actually be allowed a 2 volt drop, and that truck would still be in spec. So you have to make sure you understand what the spec is and make sure you're testing it accordingly. So covering voltmeter, key thing first is you have to have voltage drop or have to have current flow in order to have voltage drop. If you don't have any current flow, it's not a fair test. What's a voltmeter do? It simply reads the difference between 2 different points. So the next thing we're going to talk about is ammeter. There's 2 different types. The first one we're going to talk about is what's referred to as a shunt meter. That is the type of ammeter that's made into a handheld multimeter. That if most multimeters have a 10 amp ammeter function, some will also have a milliamp function, which generally is 400 milliamps. There are a few multimeter brands out there that have a 20 amp, but no matter what, make sure you understand what the limitations are. Before you use that meter, you can check that internal fuse without opening up the meter. Again, put your meter on ohms, take your red lead and put it up in the port where your 10 amp lead should go. That allows you to check the resistance of that fuse inside and tell you if it's good or bad. Again, most meters, if it's good, it's going to give you a very low or a 0 ohm resistance reading. If it's blown, it's going to give you an OL. Now, there's always some exceptions. Someone's going to have some weird meter I'm not familiar with, but that's a pretty good standard thumb rule to check that fuse. Talking about that fuse too is these are special fuses that no matter what, I don't care how much you use your meter, at some point you're going to do something foolish and you're going to hook up your meter in the wrong setting. You're going to blow that fuse. It did exactly what it's supposed to. It protected your meter. If you see in the slide right now, the one on the right is the 10 amp, the one on the left is the 400 milliamp. These are special fuses, or it's what referred to as a fast acting slow blow fuse. What that means is they'll handle that 10 amps all day long, but if you exceed it by very much at all, they are designed to blow quickly to protect your meter. So if you do blow one, sorry about your luck. You're going to go spend $15 to buy a new one, but spend the money, replace it, make sure you're good to go. Do not ever replace this with a Wrigley's wrapper, a 22 shell, or a fuse out of your old pickup truck. You have to use the right type. Now, hopefully show you something that will protect you from blowing that fuse. Again, just like the paper clip, we got a high-tech tool we came up with years ago. Is go to your parts room. I'm sure you got some inexpensive little inline fuse holder. Put you a couple clips on it and use it before you put your meter in line. One of the biggest things people ask me is, why would I ever use this? Why do I need to use this function on my meter? Well, you got that one truck. Every Monday morning you go out there and it won't crank. Dead batteries. Well, it's one of two things. You either have a defective battery that's sitting there pulling down the pack, or you've got some sort of a parasitic load. And every truck has parasitic loads. It's just a matter of, how big they are and how many there are. Parasitics, doesn't matter how big that load is. If that truck sits long enough, you're going to be dead. Doesn't matter if you get shot with a BB gun or a cannon. If you die, you die. But if you get that one truck that doesn't start or doesn't crank, we want to check it. So right now we got an oversimplified drawing of one battery, one positive cable, one ground cable. That's not very accurate for today's trucks, that you've got 3 or 4 batteries and you've got multiple cables going to those batteries. Again, you may have 2 cables that go to the starter. You may have cab feed, charge cable, depends on the truck, but you're going to have multiple connections. What you want to do is, one is we always recommend doing the ground side. It's just safer, less likely to have sparks. So you're going to have to round up all your grounds that are connected to those batteries and bolt them together so you have one common junction point. Put that fuse holder in line. If it doesn't blow, it says, hey, you're under 10 amps, you should be fine to put your meter in. If it does blow, now you got to go through and do some more investigative checking to see what is my big load that's staying on. One thing you do have to be careful about, though, is all your electronics that have a memory also have little capacitors in them. All those capacitors are designed to help keep those devices running. Whenever you disconnect that cable, that electricity is wanting to stay flowing. So you'll see a little spark as you disconnect it because those devices want to stay powered. They're going to jump that air gap, trying to stay powered. Whenever you reconnect those cables, all those electronics are going to try to reboot and recharge those internal capacitors, especially things like inverters. Inverters have very large capacitors in them, and you will get a pretty good spark whenever you reconnect them. I say all that to say this is, you want to be very careful whenever you make and break that circuit, because you can get that inrush current. So with your fuse holder in line, take your meter, again, set it up to amps, move your red lead over to the correct position, and you want to put it in parallel to that fuse holder. All you're trying to do is make sure we're not making and breaking that circuit. If you had it hooked up like this, and you had a 2.5 amp load that was staying on this tractor, what would your meter display? Just give you a second to think about it. And the answer is, basically what the meter showing on the screen right now, about half of that load. Why is that? Because you would have half that load going through the fuse and half of it going through your meter. It's got two different paths. So once you take your meter out, or that fuse holder out, now it's only going through your meter. It's going to give you a very accurate reading. Says, hey, I got a 2.5 amp load staying on right now. The reason I stress that is if you forgot a ground connection somewhere on those batteries, are you going to get an accurate reading of the parasitics? No, because you're not registering it at all. So just a handy way to make sure you go through those steps and do your checks. Now, a couple things you got to be careful of is whenever you disconnected the batteries and you reconnected them going through your fuse holder, every device that was electronic, what did it just do? It just woke up. You know, if you got tracking systems or whatever, they're looking for messages, sending messages, you know, looking for GPS, many different things. A lot of those devices will go into a sleep mode or maybe even a deep sleep mode after they sit a while. But right now, everything is, you know, electronics are recharging from being connected and devices are searching and doing communications. So you may have to let this thing sit for a few minutes or maybe longer, depending upon your fleet's electronics, and make sure they actually go to sleep. The other thing too is all this told us is we do have a load. We got 2.5 amps staying on. What is it? No idea. You could have a bunk light staying on. You could have a bad diode and an alternator. You could have a bad relay, any number of things. The only thing you can do is start pulling fuses. You may have to go get a buddy who says, hey, watch my meter, see what it does when I pull this fuse out. Hey, I pulled the headlight switch, no change, put it back in. Pull the HVAC fuse out, no change, put it back in. Take out the courtesy light, suddenly it drops down to 0.5 amp. Tells me, hey, there's something on this courtesy lamp circuit that's staying powered. Well, it could be something as simple as, well, you left the door open. Close the door and check it again. But you're going to have to go through step by step and find that circuit and then also see what's on that circuit. It could be, again, a bulb staying on, a mercury switch that's allowing the light to stay on, defective light, don't know. May take some time to go through it and find it. But you can accurately find it versus having to go out and jump start that truck every Monday morning. The next type of amp meter we're going to talk about is a clip-on or inductive. That an inductive or clip-on amp meter takes its readings based on a magnetic field or magnetic flux that's generated from electricity flowing through a wire. Anyone's ever done stick welding, you got your two big cables laying next to each other. You strike an arc, you'll actually notice those cables will try to repel each other, that they are creating a magnetic, you know, field around them that's opposite. So just like magnets are going to try to repel each other. But on the screen right now, you see what's example of the right-hand rule of electricity. This is a positive cable. If I put my right hand on that cable, I put my thumb in the direction current flows, look at the way your fingers wrap around that wire. That is the way that magnetic field is generated. So if you're using a clip-on amp meter, which we'll show you here, oops, I got some slides out of order here. This is a clip-on amp meter. If you notice, it just clips around the cable and it generates that magnetic field. If you were to put this meter on backwards, based on that magnetic field, just like, you know, we talked about the voltmeter, it's going to give you a negative reading. Doesn't mean there's anything wrong with it, that if you're checking an alternator and it says negative 150, alternator's not sucking 150 amps, you simply got it put on backwards. Or if you're checking a lift gate, doesn't mean the lift gate's, you know, generating 150 amps, it's on backwards. So just be aware. Sometimes based on the meter and the cable you're trying to do, in order to be able to read it easier, you're going to have to flip it, you know, opposite direction. Whoops. Yeah, we got some. Apologize for that. Yeah, we got some slides loading wrong. But a clip-on, very accurate with the, you know, if you buy the right type. When I say the right type is just like anything else, you get what you pay for. Depending upon what you're trying to test, the size of the jaws can make a huge impact. You know, I've got one that, you know, will read up to 2,000 amps. It has a very large jaw. The problem with that is it's not going to be able to be nearly as accurate on small loads. Quality of them, and how well are they shielded? So things you got to be aware of when you do look at them. If you use them correctly and you buy a good one, they can be very accurate if you do the right things. Number one is the jaws have to close all the way. If they don't, you're not going to get an accurate reading at all. The other thing is you have to make sure you zero it out. And if you look at it, most clip-on ammeters now have a zero button. It used to be that you had what was called a thumb wheel, and you pushed it in, you turned it, left or right in order to zero it out. What a pain it was. You went from -8 to +12, back to -5 to +13. Again, most of them now have the zero wheel. Again, it's either going to have a arrow molded into the jaws, or it's going to have a sticker in there to tell you the direction of current flow. You got to make sure you are looking at the right one. But what does an ammeter do? Simply measures current flow. In order to have current flow, though, what do you have to have? You got to have voltage pushing it. If you don't have any voltage, you can't have any current flow either. Next thing we're going to talk about is an ohmmeter. That, again, is one of those things that everybody uses, but people don't always use it right or don't always understand what that ohmmeter's telling them. So I've got a test for you. Obviously, I can't see y'all, but a good self-check of yourself. You got a service bulletin. Service bulletin says you're going to check the XYZ sensor. The XYZ sensor should have a resistance of at least 6K. So you put your meter across it. This is the reading you get. Is that sensor good or bad? Give you a second to think about it. But spec says it should be at least 6K. So is it good or bad? Would you replace it? The answer is the sensor's good. All the manufacturer was asking for was a resistance value of at least 6,000 ohms to be considered an open or an infinite reading. Your meter doesn't say 5.46 ohms. If you see that big M there, that meter is actually telling you 10 to the 6th power. So that is 5,460,000 ohms. That's a bunch of them. Go through a few more here just to kind of test everybody. This one we have a 99.0K. How many ohms is that? Instead of an M, the K means 10 to the 3rd power. So that one is 99,000 ohms. One thing, if you go through my station at a tech event or whatever, if you don't write it all the way out, you don't get credit, because how do I understand what that meant? So I think we got 8 or 10 of these total. So here's another one. How many ohms is that? Again, it's an M, so that is 9,580,000 ohms. Next one, it's at a 0.9, but it's still on the M scale, so that should tell you immediately when you look at that, you're just under 1 million ohms. Another one here, 9.76K. Now, one thing, I'm a stickler. I always make people write it all the way out. And that can either be 9,000 or 9,760 ohms like it is on the screen, or you could write NINETHOSAND, as long as it's all the way written out what it is. Now, I'm a little bit of a stickler, but at the same time too is I try to be fair. So I always tell people, hey, round it up. Quick, easy answer. How many ohms is this? 21.71K. Quick, easy answer, that's 22,000 ohms. I'll accept that because obviously you still understood what that meter was telling you. This one jacks with people. That it's 0.546, but it is K. So how many ohms is it? It's actually 546 ohms. Most multimeters, if it's over 500 ohms, automatically put it on a K scale. But people at times want to add more zeros to it. So technically it'd be a straight reading of 546. The one 14.85 K, again K scale, or 10 to the third power. So 14,850. Got two more for you right quick. There's another one that's just under the K at 0.9. So I'd even take 1,000 ohms on that. Again, you understood what that meter told you. The last one here, 3.239. So 3,239. Once you get used to it, it makes very good sense. But we do have, again, tech events. Many people miss it because they don't remember and understand what that meter just told them. Why do they do that? Because nobody wants to buy a multimeter that's 10 inches wide, so they have to abbreviate it somehow. Another thing you got to be very careful of when you do some of these is, again, the quality of meter you buy. The X-Techs and Flukes, most of them will go up to 40 meg or 40 million ohms. I've seen techs out in the field using meters that only go to 4,000 ohms. So even just that surface voltage on the one that has to be at least 6K on a meter that only goes to 4,000, if he tried to check it, it would read OL, saying it's above 4,000. First, reaction would be, oh, it's open, it's infinite, it's, well above. Well, what if it actually had a resistance of, 4,500 ohms? It's above what his meter could read, but it's not high enough to meet that spec, and you would wind up leaving a defective sensor in that situation. Okay, we're actually going to apply some of this right quick. That 5-pin relay, every truck's got a whole bunch of them. How does anybody ever test them? Well, I know how most people test them is they find a relay that they know works, reach over, honk the horn. Hey, horn works, let's swap it with the horn relay. Well, way back when with relays, they were much simpler, and so was the truck, and you could get by with that. Now, what controls a relay? It's not a simple 12-volt toggle switch or something anymore. Now it's some sort of a module that whether it's the ignition switch or blower remote or whatever, it sends a signal, and a control module now opens and closes that relay based on what it needs to do. And if your relay is defective, it may still quote unquote work. It clicks, does not mean it's a good relay. So the first thing we're going to check with this relay, we're going to grab our meter, we're going to put it on ohms, we're going to go across the coil. On this one right now, it says we have a resistance of 102 ohms. Very important. Is that good or bad? If you don't know what the specs are, you can't even answer that question. I went back through, I know the manufacturer and the model number of this relay. I could go back through and I said, hey, this particular relay should have a spec between 100 and 105 ohms. I'm right there in the middle. I know this relay's good. If you use Ohm's law, you take the voltage, which we're going to use 12.5 volts, divide it by the 102 ohms, says that relay should pull 0.12 amps when it's activated. Life is good. Everything's working like it's supposed to. We're going to check a different relay, though. We check this one, go across the coil, we get an OL. If your meter's set up properly, you're using the right scale, what that should tell you is that coil within that relay has a broken strand. I don't know if you've ever taken a relay apart, but there's a little metal core, and it's got a ton of loops of very light gauge copper wire around it. How many loops? I have no idea. I got bored trying to count them. But somewhere, we're going to say 400 loops in there. Somewhere in those 400 loops, there's one loop that's broken. So that relay cannot work because it cannot generate the magnetic field to activate. We're going to grab this one, go across it with our ohmmeter. This one only has a resistance of 54.2. Does it work? Technically, yes. You can hear it click, it's doing its job. But if we take and do the calculations like we did before, oops, bear with me. That we still use the 12.5 volts, but now we're going to divide it by the 54.2. Now look what that did to our current draw on that relay. It went from 0.12 amps to 0.23, almost doubled it. That control module or HVAC module or SAM module, whatever controls this, it could damage it because you're pulling too much current through it, or it's going to shut down to protect itself. If you don't understand what it did, a lot of times the first reaction is, hey, I got a bad module. So I'm going to replace a $300 or a $1,000 module or whatever. What's actually wrong with this truck? A bad $3 relay. So it's not simply, does it click and work? We have to go through and actually do those checks. So what's an ohmmeter do? Simply measures resistance and tells us how the resistance is between those 2 points. Usually on meter on the same knob function, we also have a diode check. What is a diode? Oversimplified answer, it's the one-way check valve. It only allows current to flow one direction. Is that 100% accurate? No. There are many different types of diodes, probably over 100. Some diodes will allow current to go the opposite direction, but for the most part, what we talk about today is it allows current to go one direction, not the other. Whenever you're using your meter, you got to make sure you look at your knob setting and also at your screen. Some meters have a dedicated diode check. Some of them, it's a shared function. So if you look on the screen right now, it's an ohm meter, it's a diode check, continuity check, and also a capacitance check. So you may have to use that mode button and toggle through until you see the little diode symbol come up on the screen. Can you use an ohm meter to check a diode? Technically, yes, you can. Is it a fair, accurate test? No. You should always use diode check to check a diode. We got a couple different examples here of just what they would show you or not show you. This is a diode out of a big like Greyhound bus alternator. Makes for a much easier picture than a little bitty one on a screen. But hooked up the way it is right now on the screen, current should not flow that direction. So we get an OL. Flip our two leads around. Meter usually will give you a little chirp, and it gives you a number on the screen. What that number actually is telling you the voltage drop across the diode. All diodes create voltage drop. Diodes are a good thing that you can control, how current flows. The bad thing about it is after each diode, you are going to have less voltage. So there's good and bad to it. This one doesn't matter which way we put our leads on, we get an OL. No current can flow through that diode because it is open. This one doesn't matter which way we put our leads on it. We'll get a, most meters, again, you'll get a consistent, chirp or beep. And doesn't matter which way you put your leads, you'll get the same reading. Says that diode is shorted. Way back when, that used to be fairly common on truck alternators because of the vibrations of the new electronic engines, and we'd see a lot of diode failures. And that would also tie into, we'd see a lot of parasitic draw problems because the diodes would fail in a shorted position and create a parasitic load. Next on that knob setting or meter setting is diode testing / continuity check. A continuity check can be a wonderful device or a wonderful function, but it can get you in a lot of trouble. That if you look at the screen, the top right picture, that's a piece of 10 gauge wire that has every single strand but one broken. Will that wire show continuity? Yes, it will. Can that wire handle any current? No. You know, and down below it, we got an example of a wire that somebody stabbed with a, a test light. Water, contaminants have gotten in there, corroded it. Is that wire any better than the one above it? No. So if you see either one of those, you have to fix them. But again, continuity can be great. That, hey, I'm looking at a truck and I should have a wire that goes from point A to point B. I can use my continuity and says, yes, it is still connected. Does it mean that wire's any good? No. The other thing too is, remember, electricity's, like me on Sunday morning, a little lazy, that it's going to find the path of least resistance. So you got to be aware of what you are checking. I see this a lot in trailer shops, that, there's wiring or lights that don't work, or lights that are coming on when they're not supposed to, or whatever. Guy grabs his meter, says, hey, I'm going to use that continuity check, see what's going on here. So he goes to the, the 7-way nose of the trailer. He puts his black lead on the green wire, puts his red lead on the yellow wire, and the meter goes beep, saying you got continuity. Say, wait a minute, one's left turn, one's right turn. They shouldn't have continuity. Why is it beeping? Well, it must be a bad harness. Well, actually, all it is it's going through the filaments of the bulb. Now, with a lot of LEDs, that can't happen anymore. With incandescents, it would happen all the time. Every circuit on that trailer would show, to be shorted, because they all had a path back to ground that it was shared. But I've seen, trailer techs, start taking entire wiring harnesses out of trailer because they were sure it was bad. So, no, go back through, pull the bulbs out, check it again. Oh, wait a minute, it went away. What happened? Again, it's finding that path of least resistance through the filaments of the bulbs. Same thing can happen on the trucks. That anything that is a coil has a path back to ground. So if you're checking an AC clutch, one side's power, one side's ground. So if you went on the power side and just went to the mounting bracket or whatever, what's it going to show? First reaction is it's grounded or shorted. No, it's not. It's going through that clutch coil. How do you prevent that? Disconnect it. Recheck it again. What is a starter solenoid or a mag switch? They have coils in them, relays. So anything that has a power on one side and a ground on the other, that's a coil. You have to isolate them before you use that continuity check. Otherwise, it can get you in a lot of trouble. So be aware. Again, that goes back to what I said before: is grab you a pad of paper and a pen, draw out the circuit. What's it supposed to do? Next thing we're going to talk about is just some of the other, benefits or, we'll say hidden features, if you will, of meter. One is hold button. That's, if people know me, know I'm not the most coordinated person at times. So can you imagine me trying to do all these screenshots of this multimeter and hold 2 meter leads at the same time? It makes it very hard. Hold allows you to freeze whatever test result you had on the screen. Very handy. Again, you're going, through that service bulletin. It says, hey, I'm supposed to have this. Well, I think I read this. You can take your meter with you and compare it. Very handy if you don't have that bulletin in front of you. That sensor, like a temperature sensor, that sensor resistance is going to change based on the voltage. So you may have to look at that voltage and temperature and go back to a chart that says, hey, I checked this sensor when it was 180 degrees, so it should be here, versus that sensor at 90 degrees, the value is going to be here. So hold function is very handy for you to have. Another function is min-max, that if you're looking at whether it's a resistance that changes or a voltage that changes, you can use your min-max function and not only see what you're looking at real time, but you can also see, hey, the lowest it ever saw was 7 volts and the highest it ever saw was 14.2. So it allows you to capture both of those. Other thing I think is probably the handier one of any of these, and it's kind of like a min-max function, but it is a relative function that you want to see what the difference was between some. I don't know if any of you ever used a scale, but whenever you use a scale, the first thing you do is zero it out. That way you're getting an accurate reading. That's what relative does. That if you had your battery sitting there and says, well, how low is the voltage dropping when I do a crank? You can put your multimeter across the batteries, you hit relative, then whenever you crank it, it's going to show you how much changed. That if the batteries were at 12.5 and you cranked and under a load, it dropped down to 11, your meter is going to display 1.5 because that is how much it dropped during that event. Or, voltage going up or down. Very handy. You can see what a change was. Again, not all meters have it, but if you do have it, it's a very handy function. Pulse width modulation. This used to be, the first time I think we ever really saw it on trucks was daylight running lights, where they were able to control the output of the headlights by controlling how much they're on and off. Instead of using a variable resistor or a resistor bank like we used to use for blower motors, now we can control the brightness of bulbs, the speed of fans, volume, fuel injection, everything by pulse width modulation. That's simply a matter of how much a device is on versus how much it's off. So whether you're checking a blower motor, whatever, you use your percentage function, and it's going to tell you, hey, this is operating at 50%. 50% of the time it's on, 50% of the time it's off. So it used to be, again, with a blower motor, you had 3 speeds. Now with pulse width, you can have basically infinite speeds based on how much the power's on versus off. Frequency, more and more trucks we have inverters. One of the things we can check on an inverter is the hertz of the AC outlet. Everything in the US is 60 hertz. You may have a driver complaining that devices aren't working properly or whatever. You can use your frequency to check the hertz of the output of an inverter. Couple wrap-up slides for you, and I do have some questions that came in. I do want to please ask y'all to not exit until you get a chance to do the survey questions afterwards. We do all this to be an asset and a good channel partner for all of our customers. So we do the survey questions, see what you thought of it, anything we can do to help you. We try to do a webinar once a month. Anything we can do topic-wise that will help you, let us know. So again, please do not drop off until we go through that survey. But this is something you can print off. Should be part of the widgets of part of this presentation. If not, let me know. I can email it to you. It's on our website. You can print it off. Or if you're at a location I'm coming to, I can bring you some hard copies of. But it gives you examples of a lot of things we talked about. What does the M mean? What does the K mean? How do you do some of these formulas? Then my one point I am going to talk a little bit about is this is a training board we made years ago. Some of you may be very familiar with it. One thing is, again, understanding electrical is more and more important every day. So we designed this actually for tech events, but we've had people that have been interested in it for internal training or even internal testing for people. And on that note too, we also made an online electrical test that you can take. If you want a link to it, let me know. I'd be more than happy to send it off. It is a way you can log in and do a online test. If you get a 80% or better, it will generate a certificate for you. Take that to your boss, and maybe he'll buy you a cup of coffee and put in your file. So different things we try to do to support y'all. So again, any questions or anything, don't hesitate to ask. And other than that, I'm going to push it over that. I am going to go through a couple of questions right quick. We had one about, how do we test the leads? I think we covered that with, touching them together on the ohm setting to, see what the resistance was. Then you go through and isolate them and check them individually. Someone asked about what brands I recommend. I try not to do too much of that on any of these presentations to, try to avoid being a salesperson. Biggest thing I tell you is, there's 2 big brands. I think I mentioned both of them during the presentation. If you want to send me an email, but buy a good brand that, do some research, find out ones that have the ability to send them in for calibration. The 2 big ones I mentioned do have programs. Examples of AC and DC was another question. Easiest thing for, to separate the two, DC is direct current. That's going to be anything automotive, a 12 volt, 24, 36, 48 volt system, anything we're going to find on, cars or trucks, that's all DC or direct current. AC or alternating current, that's going to be your house wiring, 110, 220. There is a difference between how your meter picks it up, so that's why there's two different settings. Excuse me, got to take a drink right quick. But it reflects how your meter reads it. So if you did have your meter set on DC and you stuck in a wall outlet, is it going to hurt your meter? No. Is it going to display something? Yes. It's trying to make heads or tails. Hey, you told me I'm on DC and I don't quite see it right, but I'm trying. So biggest thing, it's not going to hurt the meter. The only thing you're ever going to hurt your meter by doing is leaving the amp probe or the positive wire, from using it as an inline amp meter if you forget to move it. If you were to take that and put it across the battery somewhere, it's going to pop that fuse. That's about the only thing you can do is blow those two internal fuses. So don't be scared of using a meter. The more you use it, the better you get. Whether it's on your day-to-day job troubleshooting it or doing tech events. People struggle a lot of times on things simply because they don't understand the best practices for using that meter or what that meter's telling them. Again, a couple of people that had questions. Again, send me a text, send me an email. I'll be more than happy to follow up any questions, information, resources that I can share that'll help you. Don't hesitate. But other than that, I'm going to be quiet and turn it over for the survey questions. Again, thank you all very much, and hope to see you again, in the real world soon. Bye-bye.